No.
Hello, good afternoon. Can you hear me? Can you hear me?
Yeah.
I've muted everybody.
You muted everybody.
Good evening, we can hear you.
So,
Thank
I want
you.
to have a mute.
No.
good evening, everybody. I want to welcome everybody to yet another session of our technical presentation. The Nigerian Institute of Mechanical Engineers Lagos Chapter April 2022 technical session. Today, we have in our midst Engineer Dr. Reverend Victor Akpan, fellow Nigerian Institute of Engineers, fellow Nigerian Institute of Mechanical Engineers. We will be discussing with us building collapse prevention and engineering perspective. Just a brief introduction. Engineer Reverend Victor Akpan is the Managing Director, Chief Executive Officer of a multidisciplinary engineering practice firm, Vikas Consults Limited, based in Lagos. He is a seasoned professional in the service engineering sector. Engineer Reverend Victor Akpan was born on 27 July 1947 in Ikot Epene, Akwa Ibom State, Nigeria. He has attended African Apostolic Primary School, Ikot, a mission school founded by his father, and Lutheran High School in Ikot Epene. Sorry, sir, for transition. Having been displaced in the Nigerian Civil War, he relocated to Methodist Boys High School, NIMechE, Oron, Akwa Ibom State, where he obtained his O and A-level certificate. He taught mathematics and science subjects at Eastern Institute Secondary School and then worked as maintenance, instrumentation, air condition personnel at Mobile Producing Nigeria Unlimited, Eket, in Akwa Ibom State, Nigeria. He obtained his first degree from the University of Manchester, a second degree from Brunel University, London, in the United Kingdom, in building technology, electro and mechanical, and building services engineering, respectively. Both degrees were on Federal Government of Nigeria and Old Cross River State government scholarship, respectively, on merit. He is in association with the respective professional bodies at different levels. Past executive member of the Mechanical Division of the Nigerian Institute of Engineers, fellow of the Nigerian Institute of Mechanical Engineers, fellow of the Nigerian Institute of Engineers, registered engineer with the Council for the Regulation of Engineering in Nigeria, COREN, fellow of the Institute of Management Consultant, IMC, Nigeria. His effort and contribution to engineering and humanity development have not gone unnoticed. Hence, some professional and meritorious awards from Construction and Engineering Digest, SEED, in 2014, 2019, and 2020, respectively. NIMechE Lagos in 2014 and 2015, RCCG FCBA Assembly Lekki in 2017, First Square Gospel Church of Nigeria in 2017, First Square Gospel Church, Alapere District in 2019, Omojuwa Ifesowapọ CDA in 2020, and Reverend Victor Akan is an ordained minister, reverend of the First Square Gospel Church in Nigeria. He is married and blessed with godly children. He played football, which he gave up at an early stage of his secondary school. He also played table tennis. Ladies and gentlemen, please welcome on board Engineer Reverend Victor Akan for his presentation.
Yes. Okay, the fellow engineers and members of the great institution, I want to thank our chair. I want to thank you and your exco for the opportunity given to me to present this paper. I want to also thank all the fellows, all the members who are either online and all those seated here. I thank you very much for finding time to listen. I believe since you have confidence in me, you will not be disappointed. As we go on, hope you will help us a lot in our professional development and also our country. Now the topic is building collapse prevention. And I say an engineering perspective because so many people have spoken about it, talked about it. Mostly I hear from the QS, Estate for surveyors, and so I've not heard very much from mechanical engineers, maybe the structural engineers, on one or two occasions, they will say something. So I believe we'll see how we fit in. Mechanical engineers, electrical engineers, how we fit in. Yeah. Okay, my introduction. Now, besides providing shelter for man, besides providing shelter to man and his activities, building has to meet quite a lot of needs, requirements in terms of protection from hazards, protection from natural disasters, and from weather and so forth, and then meet or the social needs of man. You see it there in the introduction. Yours may not be able to know. So the environment where man works and lives and works will be safe and comfortable, and to enhance productivity and enhance social interaction. So please, the paper is there. You can just see it. But let me just so that I can short it. To realize the building product, so many professions are involved. The engineers, the architects, the researchers. This time is small. It's small. So, no. Just enlarge the yeah, this better. Thank you very much. Right. I said, besides support for equipment, the building must withstand all the forces of nature, wind, snow, rain, flood, etc., that impacts on the building in a given location. It might be a marine environment. It might be a desert condition. It may be, we all know that different regions of the world where you have snow, where you have very unfriendly sun heats, and all this. Building must withstand all the strength that comes to it. Buildings are designed to meet safety standards for people and equipment, and also meet the social needs as well. So it must be fit for purpose for different kind of things. It can be healthcare, it can be hospitality, the hotels, it can be residential, it can be recreational. All this must be. So quite multidisciplinary approach is required. It's required. And then the building must be fit for purpose. And then, like any other thing, any other product, it might fail sometime, and failure takes different stages. May fail to perform it may fail in terms of performance and no longer meeting the purpose for which it was designed, or it may be physical failure that manifests in the form of collapse. Okay, so, and that is when we even know building has failed. The building will have so many things may fail in it. The electrical system may fail, the water system may fail, the HVAC may fail. It's not noticeable. You may not notice, except only the people who occupy it. They may feel the discomfort. They're no longer meeting their needs. But the physical failure that manifests in terms of collapse is the one that attracts attention nationwide, worldwide. And it comes with some, consequences. I put down here, please, I think this, I say many factors contribute to building failure, collapse, and just put some there, see, badly designed foundations, inaccurate assessment of loads to be supported by the building, bad soil with inadequate bearing capacity, poorly designed building elements, e.g. columns, beams, walls, support for services, etc. before I go on, this building here, the systems that provide comfort must be integrated into it, and it must be supported by it. So there is weight on the building, there's stress, there's strain on the building. The building must be able, to withstand all this. And failure to do this may result in feasible failure or collapse. Now, use of substandard materials, non-compliance with known or relevant standards, then poor supervision, bad implementation, construction, installation. All these are things that can constitute to building collapse. So let's move on. The process of building creation and realization or rehabilitation involves stages, but mainly design and implementation. That is construction. The professionals mainly recognized to be involved includes the architects, the structural engineer, the services engineer, mechanical and electrical, the quantity surveyor, technically cost accountants. The implementation often involves main contractor, the qualified builder or civil engineer, subcontractor, mechanical, electrical, specialist contractor, usually like lifts, catering and all that. When the quantity survey itself, I will let you know some functions of these people soon. Often these professionals may not be properly assembled before commencement of the building design and implementation. And implementation may also suffer. Same. The choice of the architect, the choice of the structural engineer, the choice of M&E, the choice of those to implement it should be certified people, should be certified, qualified people who have had experience, in these things. But this may not be so for the so-called aim of saving costs. Building, I may add, it's not here, stand on three main criteria. The structure must be sound. One. Number two, the building must function. Number three, it must be economically sound. There's no point wasting a lot of money on something that should cost maybe 1/4 or so. It's not acceptable to society. It's not acceptable. So that's it. So you need quite a good number of people to be involved in the process. This point also to say that maybe the research institutions, development of strength, improvement upon strength of materials, improvement on methodology, finishes of all these things that we will stand, strain, stress, the research institutions should also work and fit into the industry. The university also should also work, carry out research on materials. If we don't do this, we settle with the status of importers. We import. And so everybody should, be involved. People should be involved, all professions, not only, when we talk about buildings, say civil engineer. You may just say civil engineer, but they say architect. They are not the one producing the material used. They are not the one producing light fittings. They are not the one producing AC. that, you know, what they want producing pipes. Right. So why should buildings require attention? The natural habitat without human intervention is not suitable for habitation for man. No, nothing is done. Grass is not cleared. No, it's not. Human intervention makes the environment where we are to be suitable for us to carry out our activities and to live in. For man to not suitable for habitation for man. Man would be coping with serious natural phenomena such as floods, bad weather, intense sun, wind force, insecurity as a result of intruders and hostile creatures. So building protects you from all this. So it should attract interest of many people. The building must therefore be strong to provide not just shelter, but protect man from all the hazards. Besides, it should provide suitable environment for man's activities. It must function to meet such needs. Responsibilities in creating the building. The architect, the chief space planner, he conceives the envelope, the space to accommodate man and his activities, whether it's creation, whether it's production, whether it is meeting like this, whether it's commercial office. So he does that. Now, the structural engineer, the stability of the structure, okay, support for all equipment and systems enclosed for the building to function. Because at this point, you know that many of us, if you occupy a place, anything you buy, you can bring into the building, provided it can pass through the door. Not, considering whether the building was designed to support. You can change a place to factory and bring machinery, equipment without checking with structural engineer whether that building can support. So long as it can come in, keep it there. All these may contribute to accumulative failure that may result in collapse. Right. Geotechnical engineer carries out soil investigation, provide report for design of foundation and wastewater management. The report reveals soil bearing capacity, water, the water table, fluctuations, among others. Underground earth is water. So the soil report will show us it's seasonal. It comes up and goes. So if down, it comes out, some buildings they are flooded. Even as water will come and flood. This water, much as it's good, can be a destructive agent. Water can destroy, even though, so it can weaken the foundation and cause collapse. But when this is revealed, then we can lower the water table by creating some catch points and do continuous pumping, and it goes down, reduce, the flooding tendency, reduces the flooding tendency. All these are revealed by this. But some people don't bother about soil investigation. They'll say it's not enough and so on. Right. Let me use the mechanical engineer designs, details, documents, services to be provided, the equipment, HVAC, water services, drainage, lift, fire fighting, all these are are carried to the building, they have weight, they have sizes, they have dimensions. If this information is not, available to it, will just work on assumption. But with time, it will take its effect. Right. The quantity surveyor, budgeting, cost monitoring, provide cost targets on envelopes for the proper for the project. Now, the cost saving, particularly during construction. I watched a video where the building was designed and so on. So, when construction starts, from time to time, the contractor will give you claims. They do valuation, they give you claims. You have to pay. And then they normally will give you details of what constitutes the claim. So, and the managing director, that compensation, all sizes of steel reinforcement that the structural engineer has specified, he said that it's too expensive. Why not use smaller ones? And without finding out what defect, and they used that, and the building collapsed. The MD was arrested. I saw this. He was arrested. Now, with proper budget and programming, you know what to expect. This will cause this, and then the timing, so that it is within project time, it is implemented without you doing a fire brigade, taking a fire brigade measure to cut costs. You should have known the cost implication. You could have target, okay, you have to, for this, divide them into section for services. Maybe sometimes you take 30% of the overall, sometimes 40%, depends on the complexity of the building, and take 40%. And then this, you call substructure and superstructure. You put all those elements, cost element, the bill of quantities will show all those things. And then there is programming, there is timetable for action. There may be device delay because, as you know, particularly in that country, the dollar, the naira dollar rate, change to that. If you can keep to construction time, you keep within the budget. Though it's hardly before a project is completed with the budgeted amounts. But you will not have to go and compromise the design because you want to save costs. This can lead to collapse, right? So specialists, health, consultant, catering, consultant, hospitality, hotels, and all that. These people are brought in during design. They will give you the type of what they want to do and the type of equipment that we use. And from there, you can give details to the structural engineer, right? You not just do afterwards, right? Now, causes of failure. Now, the design negligence. Failure can be traced to poor design, non-compliance compliance with standards, right? I've worked with some people, they don't even talk of standards to them. Just what they see they can do. It's necessary for us to do this. Another one is using unqualified personnel. Unqualified personnel, when you use draftsmen to do what an architect or a structural engineer should do, all right? You expect what to expect. Now, copying other designs rather than specific design for the project. Typical example of this, one of the projects, I got a geophysical engineer. He was commissioned to carry out soil investigation and give report that will fit into, other design activities. He didn't do, he copied the nearby something, right? And when, in the process, we say, okay, let's confirm this test, what he has given us. The contractor carried out test and it was totally different. Now, meanwhile, the foundation was based on that. So they had to change the design of the foundation. If that was not done and you carry on and do build on that, the obvious can take place and will take place. All right? Then, wrong side report, use structural detailing which do not belong to the project. Draftsmen will copy what they will give to somebody, client will take it. Because they don't want to go and pay the end. Meanwhile, that detailing, that is not for that project. So when you use that, then what do you expect? Okay. Now, so structural detailing, which is where I'm that improper assessment of loads to be supported by the structure. The services engineer may fail to provide information on chillers, generators, boilers, tanks, lifts, and escalators, machineries for all these things. I have been these things for 40 years. Sometimes because the time involved, because the effort involved, because they just assume. Chillers are heavy. Sometimes they are put on the roof. Tanks, great weight tanks are heavy. Sometimes they put them. If not on the roof, they are put on some other floors. They are heavy. So accurate information on this should be made available to the designers. Should be made available to the designer. If not, and of course, normally, particularly in our own climate, there's always urgency. You don't give sufficient time for people to study and find out the characteristics of the environment. You know that what you have to do, environmental impacts, you have to do all that. And one of these, like I said, you have flooding. You have to study and know if you don't control waste water, if you will drain it out and keep it, it may affect foundation. Right? And this information is required by the mechanical engineer as well as civil engineer. As well as you do drainage, you do surface drainage, you do the one I've mentioned, you get into a pit and then you pump up and keep the place. You have to control flooding. And this also, if not checked, can contribute to failure. Now, say, non-establishment of services routes, pipes, ducts, cable, ways, etc. during design and resort to arbitrary openings on floor slabs, walls, beams, and other load-bearing elements. This, when done post-design or post-construction, may weaken the structure and pave way for failure or collapse. Now, it's, just, because you want to move pipe inside, just open the wall. Or once you want to take some drill, open the floor. And things like that. Some of these things, pipes are big. You are carrying chill water. You are carrying particularly pressurized system pipe work. They, will go with force, with vibration. They will, all these things will affect the structure. Will affect the structure. If you don't give schedule of all the holes you require, okay, penetration of walls. Some walls are load bearing, some are not. So for you to go through load bearing, the structure may not allow you. But if early enough, you say you are passing through, they may design either a beam or so to permit passage. AC ducts can be big, very big lines, and you want to move, particularly renovation work. Renovation work is more complex and more difficult than new work because the building is already in place and you are coming to change the AC system, change the water system, all this and that and that and that. You'll be puncturing holes, you'll be creating roots, cable roots here and there and so. All this can affect the building integrity, right? Okay, and pave way for collapse. Now, non-determination of occupancy rate, population designed to be accommodated should be determined and designed for. Human beings constitute life. There is the kind of the loads that come, they are categorized. You have dead loads, you have life loads, and you have imposed load. All these, there are code of practice that are responsible how you can access all this. All right? Now, human being, you know, the traffic, you know, it varies. At a time like now, you have a few people. At another time, this place will be full. We are not people without weight. We are not witness. We are not witness. So the most time to ask what is the population designed for? We don't give you answer. This is wrong. Population affects so many things. Apart from the live load on the building, the facilities, water, gas, you need AC, everything, you know, require population information. The thing we neglect. Occupancy rate means if you are doing this, this is maybe a hall, we are doing this, there is what they call square meter per person. It's published. The British have standard for it, occupancy rate. And if you put more than that, they say it's congested. This is information that we neglect. Often they bring building for you to do AC, put power, put this, put this. What is the population you have in mind? There's a building we designed here for multi-national company. They gave 700, but one other time they come and say the population we have in this building is about 200. Yeah, it's about 2,000. So I mean, how do you disaster? They don't just happen; they are costs. Now that is even then. If it's in the residential, you now partition and let out to more people. They bring more equipment. That was envisaged at design. So it put the building more stress. The outcome of it, right? Let's move. Now, rising dam, moisture control, rising dam, sort of weaken all those places. I don't know. It will go. There is, for instance, in Britain, there is a regulation on how you control moisture. Rising dam, they have along the when they're concerned, they put a what they call a dam roof cost. That's what they call it. That stop water rising up. And then on the German floor, they put a dam proof membrane that can stop water from water. Like I said, is good, but it can be destructive. Right. Lack of proper supervision by qualified personnel. The purpose of project supervision is to ensure compliance with design specs. If you go and bring people who don't even know the implication, they don't even know. One Indian, when they came to my office, they did a project in Abuja. The person doesn't even know the difference between chill water system and BRF. There's a consultant supervising them. Because you put your own person there. Or because you don't want to pay for a qualified person. He doesn't know what they, and then corruption, I didn't want to put here. If you collude with corrupt contractors, and the shortage of materials or substandard material, you are not doing good. You are not doing well. It's laying a background for collapse. So these are the things I have observed in our industry. I work in the UK, it's different. It's different. Everything is, in fact, computer will tell project completion, everything. What will be there? You go and check before a contractor closes, whether it's pipe you are running here, before it covers it, you go there and inspect the correct size, the correct material. Will be there. The correct one before they cover. If they cover without inspection, when you arrive, you ask them to open. And when they open, you check. They have to make good at their own expense because everything supervision has procedure. You have to give notice, sufficient notice for it to be witnessed and supervised. All right, let me, leakage in engineering systems. Where is that? Building materials. Okay. All right. Where am I? Where am I? Use of substandard, poor workmanship. Plenty. It spans apart from building roads. You do before you know it's peeling off. Before you know, the pipe work that is supposed is leaking. It wasn't properly, so it wasn't properly tested. So many things, you know. These are the things, right? We have to prevent poor sequencing of activities, critical part. I've said this. All these fire brigade, program everything. You should know. Why they give time? When you talk about man hours, man hour. How long will it take a competent person to erect this wall from here to here? They have time, they have everything. So when they are budgeting for work and they are planning for time completion, and the person they know what time it will take to finish, and they also know the cost because you pay man hours. We don't value all this. In fact, we want to press on it. You inconvenience our colleagues. Right. So now the poor sequencing. Now lack of maintenance. Building materials have lifespan, and with time, deterioration in performance, failure to replace applicable elements may give way to collapse. They have lifetime. Sometimes our pipes leak. They don't expire now. Sometimes insulation, you have maybe a condensate pipe as a part, so the water begins to drip. You know, sometimes I think I try to stop using underground water for tanks. The step is very, very critical because that, you see, where you have waterproofing quality of either the finished, I don't know whatever. I found out it lasts for only a time. But if you are using that tank for potable water, drinking water, you know, there can be pollution by underground water. Because that thing will fail. Its lifetime will expire and water begin to penetrate. And you are still using that and drinking and doing things. Right. Now, so, right, leakages, that should be, you know, checked also. Then, of course, in design, something that you have leak detections. And then some, you know, automated building today, you have to carry so many things. You will detect. But you can neglect it because of maintenance attitude, mindset. You can say, leave it there. But it continues. It will cause dilapidation, it may cause failure, it may cause collapse. You know, these material, they are gone. And we don't even follow what the manufacturers tell us. Did they put things manufactured best before so time? Right. Some support elements of the engineering equipment, tanks, may show signs of failure. When we neglect see, we don't take, that's maintenance I'm talking about. When I hear people say going for facility maintenance, it's attitude. I don't like seeing something that doesn't function the way it was designed to function. Once it does that, it can lead to so many other failures in the system. It's designed to, when you talk of commissioning, it's making it to work to design condition. This is how it should be. But when you start neglecting all this, the system will go riot. Right. Okay. Natural phenomena. Yeah, I thought with foundation itself. the structural engineers talk about underpinning. You know, working with them, I guess this means what remedial measures for foundation which show signs of giving way. You may neglect, but it's a disaster waiting to happen. Natural phenomena, water flooding can cause failure and collapse with its attendant consequences. Some causes of flooding include rainwater, underground, I've mentioned that water, and fluctuating water. I mentioned all that. The water that comes, design must collect it in terms of rainwater drainage, collect it carefully, and dig them out of the building. All right. So the differential settlement, differential movement of foundation of the building can cause uneven distribution of stress, resulting in cracks and collapse. You see, you know the soil, you know, different here. I remember very well in the UK, they do soil strategy. They give you how it look like. Put the map there, you see if you are going to Shomono, you see how the biological look like. If you are going to do something there, you know how far you should go. The same thing with even water. You know how far you should go to get aquifer level. So when you go there, you don't still do confirmation. Because with time, things can. So we are talking about the climate warming, I mean, that means things are also changing from the known pattern. So all this should draw attention. So now, so but it's something that the engineers predict that right from the wind force, wind strong. So the engineers, structural engineers will take care of that. Strong, right. If it was not, the roof will be blown off. All right, you see, two buildings will be there. Wind comes, the roof of one is up, one is there. And then, of course, on the wall itself is there. Free, okay, fire. Fire prevention is another topic entirely because the building here have what you call fire resistant quality. Right? The integrity must be sustained for a period. It can be 2 hours, 1 hour, 1 hour. So during design, that is taken care of. And of course, the engineer, the electrical engineer, mechanical engineer, they make provision for this. The detection and alarm when fire takes place. It can avoid disaster. It's designed. Detection, fire detection and alarm system. Then the mechanical engineer will put first aid equipment like sprinkler, the hand using and goes with, then permanent fire brigade equipment, hydrant that they will come and when fire got a building, it will weaken. With time, it will collapse. So prevention is also a measure. Of course, there are other things like what I don't know what I meant, lightning protection. Lightning for the engineer designs when thunder strikes, it conducts heavy currents in kiloamps. There's a way of conducting it slowly into the earth without damaging building. Of course, there are other things like bonding of all metallic things and equal potentiality around so that human beings are not affected. Right? Prevention measure, the final things. Personnel, qualified personnel, there is the problem. I think there was this thing. I belong to building prevention, building collapse. Yes, well, you see there were protests all over. Some people don't want to use qualified professionals with proper proven experience should be appointed to undertake building design and implementation. Codes and standards. I don't know. Codes and standards should be in place and updated periodically as necessary. The designer should have access to national standards like Nigeria, clearance standards. If you are designing for oil companies, they have their own. And then you have international, ISOs international. They would tell you what obtains in your environment take place. They don't live there, but they give general thing. But I put there the most stringent of those should apply. When you don't have standard at all, you do anything. You do anything. Also, in the building, we went some. I work with some international consultants. Where comes Victor? What standard is it? Victor said, okay, right. That's the question they ask. Even in top rental places, people from outside wanting to, they know who I do a designer. They want to know designer. And I what standard? They say, okay, yeah, okay. So you ask that, because without standard, anything happen. Now, put there the most stringent should be please. So sorry for your time. Coordination, interprofessional relationship in building design and implementation is key to achieving excellent building product. Information flow should be effective. The building services engineer, mechanical and electrical should provide information on equipment, their physical dimension, weight, and location where it is to the structural engineer for the design. This can be presented in a form of schedule of equipment, schedule, and give all the information. It will know if you have what the slab that will support this here. It's not just anywhere. Services routes, where and where to pipe the ducts that will pass, walls and slab penetration, where they will penetrate the walls, where they penetrate the floor to another floor, their sizes and support requirements. Manufacturers will give you the details, how you should install it, and so on. So all this keep to the, not that you are in one corner doing one thing, the other one corner doing thing, you bring them to feed. It won't work. It won't work. It won't work. Because there are well called installation methods, how you install it. Now, services rules, okay, right? Avoid inappropriate opening. Don't open anywhere without clearance of holes on slabs, walls, beams, which may weaken the structure. Your technical engineer should diligently carry out soil investigation for accurate information regarding soil characteristics, its bearing capacity, and underground water implication. Building loads are transmitted through its elements, columns, load bearing walls to the foundation, then foundation to the soil. I see some people, column will start from there and stop here, another column from here down. They don't know. The building is designed from the roof to the foundation. You calculate all the load from there, from the time we go to the soil. It is transmitted through those columns. They are not put there for fancy. They are fancy columns anyway also. Yeah, but they are this one, load bearing column. They was. So when they go, they transmit to the soil, okay? And then the soil might have adequate bearing capacity to bear the load. Where that does not happen, collapse will go. Fire prevention, a different topic, should be guaranteed in building design. Use of trained artisans, all these, I think Korean has done a great thing now. We now give categories of everybody, right? You can register as a technologist, you can register as a technician. So all it means is certification, that they know what to do and they know the implication of not doing what to do. But just carry anybody there. Then. And normally the building can be so busy, you don't have time to, and they cover everything. You don't know, this thing will happen. It will happen with time. Conclusion. The building environment is meant for man to enjoy his dwelling, his workplace, recreation, and social interaction, and thus demands the best of intentions in design and implementation in order to avoid collapse. We should know, embrace, and employ codes and standards in the building being designed and built. Periodic certification 5 years, 10 years, 15 years, 20 years, should be advocated and written into law. This includes periodic integrity checks, audits, and certification. The building that we do audits. Everybody, I saw somebody say it's not only structural engineer that will do integrity. No, because the equipment there may be having some adverse effect on the structure. You must detect and know it's working, it's not working. And of course, as you know, we don't really retain electrical things brand new because you know the electrics the way they do it. But pipe work also depends on the age. We may keep a new leaf of life. And if this is done periodically, before the disaster happens, it's checked. The building is there 20 years or so, nobody really knows whether it is performing. The engineering systems are okay, the structurally is. He said, what I'm telling you, you see some village and see exposed, that's what it's called balance and unbalanced failure. When the concrete's off before the steel, that's unbalanced. When the steel bends, and you have, I don't go into all those other details because it's still this presentation. You know, there's a bending moment. All of us, I think we know what the bending. When you have to and you put something, you load. The deflection, it can go beyond limits. I mean, lead to collapse. The column, when you load, you must stand. Otherwise, you walk. You do like this, and you give way. So all these are the things we have to rise up in our society and not let all those people from there and they come to do for us. Right. Training of personnel should be given top priority. The use of qualified professionals should not be compromised. Buildings should be well planned, including budgeting, so that you don't do those cut costs. Okay? Budget should be part of the plan to avoid inappropriate cost cuts. I want to thank you for giving me confidence. As again, I thank the chairman for giving me the privilege. God bless you.
Thank you very much, sir, for that beautiful presentation. I want to say a very big thank you to Reverend Dr. Victor Akpan for that beautiful presentation. If you have any question online, please raise up your hand so that we can call you to ask your question. Also, people in the hall can also ask questions. Anybody that wants to ask questions? Can you hear me? Hello? Anybody that wants to ask questions or contribution? Okay. Any question or contributions? It's especially from our fellows. Yeah. Yes. Somebody has confirmed they can hear me.
One mechanical area, not well educated or not well designed. You said it weight mainly, section of weight of is it the equipment or in whatever, or fashion into the building, or space wise. I just want you to stress more on that bit so that we actually understand the effect of mechanical equipment weight on buildings. Thank you, sir.
Please unmute your mic. Your mic is mute, so please unmute.
Right, that is one, anti-vibration. And the space the equipment will occupy, then the weight, because there's the instructor will talk about point loads, right? It's particular points, okay? The load, that equipment may be more than the loading of the floor, but they'll ask for the load, the weight of the equipment and the size. Of course, the size, the architect needs to know so that we can provide the space for it. Now, what the implication is that our people who are mechanical engineers should be thorough in design by providing schedules of equipment that give all the information for the designers will need. Right? And besides that, during construction, it has been carried by crane. You need to know this. So it should be as thorough as possible, detailed. You see, when they're writing this thing, I didn't bother because maybe we say, they come because it's we've had, for instance, during that we put boilers on certain floor, the structural engineer said we should remove them. And that slap cannot. We have to remove it. Even chillers, we put chillers and say, take it down. Even pipe wall, say you cannot penetrate that. That will take a longer way to come. You know, in design, roots is the best, is the shortest between source and supply. Right? What the pump characteristics, the loss of frictional loss and so on, so on, so you will reduce it. But because that particular, you cannot penetrate it, you have to go where we could and then come back. Right? Okay. So that's how mechanical engineering can impact. And when you talk of location, you know railway tank is heavy. It's heavy. You put them on the roof for water supply. Now, I don't want to make generally services in our government they are not very important. You can take that all in our but there is what they call simultaneous demand. That the flow, if 10 people are here and opening the tap, this is the minimum flow rate. So even if people are using a move that time, we still have water. You don't have to wait. The standards should be emphasized. I didn't have to talk about. I think I was part of our chapter committee on standards at the time. Where are we? But I also attended, represented the NSA, was asked to this chapter on Nigerian standard organizations where I attended was some series of meetings and so on. And said Nigeria there was a memorandum of understanding that Nigeria could be using anti-standards. But mostly my design, that's what I use. But because we have people train in different parts of, some use America, some will use Europe. There's Europe also. Okay. All right. So the mechanical equipment in building is enormous. the lift, that it traverses on the floor. You know that? You know it has weight. It had to be supported by the structure. Right? Okay, so that is one part. Then AC. When you carry dock going here, going here to go and supply is central AC. You will go through either from floor to floor or from room to room. You penetrate structure. And all this will cause some weakness. Yes, it's allowed.
Thank you, sir. Once again, want to thank the presenter of today's technical session, Engineer Dr. Pico Akane FNSC. Thank you so much for taking your time to prepare this beautiful presentation. We have all listened, and I believe we have gained a lot from what we have presented today. To our members, we are going to send this to our platform for you to have more of what has been presented today. And before we round up, I want to recognize one or two of our senior colleagues, Engineer Adeniyi Ogulusi, FNSC. He's always joining us, though from diaspora. You're welcome, sir. I will also want to recognize the presence of two of our former chairmen. They are online, Engineer Amos Komalafe and Engineer Ebupade. Thank you so much for having time for this evening. And one of our senior engineers, Engineer Aju, you are welcome. We recognize everybody online and those that are present at the venue. Thank you so much. We are almost.
There's a question.
Question on the chat.
I will take
it. What is the question, please?
The engineer NIMechE Aluzi said, I would like Engineer Dr. Akpan to speak on the importance of ventilators and kitchen film extractors.
To importance of ventilation.
And kitchen film extractors.
That's good. That's good. Thank you very much. Because it's not part of, it's not collapse. We are talking of prevention of collapse. Okay, for environment, we're even talking about thermal comfort. Talk about thermal comfort. You talk about thermal comfort. If you are talking of air conditioning, it's not just the cooling. It's the air quality, freshness of the air quality. All right? And then, of course, the temperature, relative humidity. So all these ones, you know, they are connected. They're connected. Freshness of the air. So now you know that biologically we take in oxygen, we put out carbon dioxide. So there must be freshness. We must remove the pollutants. That's the function of ventilation. Remove the pollutants and put fresh air so that we see continue to breathe oxygen. Now, if that's not for today, if it was today, I will talk about thermal comfort. Because if you continue like that, taking it, those will be breathing the polluted air and so on, so the carbon dioxide, it will weaken you, they will fatigue, the production will be used, and it can result in death. Now, for kitchen, the same thing, kitchen, there's pollutants. The smell, the odor, something, so you must extract. There are standards concerning this. For kitchen, you have what they call HN rate per hour. HN rate. Even for everywhere, you have ventilation standards. Okay. So the importance is to promote healthy living, productivity, and comfort. Wait, I think that's what you asked.
Yes. Okay, thank you very much. I think we are done for today. Before you go, we are presenting the presentation online. You can see on our screen the certificate of appreciation to Engineer Reverend Dr. Peter Udo Akpan for sharing his wealth of engineering knowledge and experience as facilitator on our hybrid technical section. The topic he discussed is building collapse prevention and engineering perspective. I believe we have learned a lot from what he has discussed today. I don't need to give somebody again. We'll go back and take it as part of our. We are going to send it to all of us online. So once again, we thank you so much.
Thank you very much.
And let us give him a round of applause.
Thank you very much.
Let's see our emoji, our love online. Let's see. If we appreciate the engineer, let's see our emoji.
You almost all of them. Guys, a thumb up from engineer Unusi. Yes, thank you so much.
Thank you.
Thank you very much. Thank you.
Thank you very much. You can unmute and talk. Can unmute and talk, please.
No, we can.
Thank you very much, Chairman.
Thank you.
Thank you, sir.
Lecturer, Engineer Reverend Doctor. That was a very beautiful presentation. I hope that very soon I'll be there physically at the meetings of NIMechE so that I can enjoy what all the other members are enjoying.
Thank you,
God
sir.
bless.
Thank you. Thank you. God bless you too. Thank you.
Yeah, on behalf of online members, Engineer Adini Ogunusi and speaking from UK. Thank you so much. Yes, we quickly add up.